Hello, this is Susan Poss. I'm still working in Chapter 6, which is all about factoring. And this is kind of a summary of all the various types of factoring techniques. And these problems, several of them, 3 of them in fact, 3 out of the 4 contain decimals, which makes them a little trickier. So I'm going to try and talk you through these. As I look at the first one, it's a trinomial. And I'm noticing that the Lie coefficient on this trinomial is not 1, which makes it one where I have to go through a little procedure of breaking it up into 4 terms. So let me start that process. When the Lie coefficient is not 1, I like to create a little table where I take the Lie coefficient 2 and this number, this positive 0.12 on the end, multiply those together, and that is what I kind of think of as my target number out there. What are 2 numbers that will multiply together to give me 0.24 and at the same time add up to this 1.1 positive back here in the middle. So I've got a lot of things going on. So multiply the 2 times the 0.12. Start to think of factors of 0.24. Now you've got a lot of combinations here because you can place this decimal in a lot of different positions and still get a product of 0.24. But I'm going to start by just working with placing the decimal in front, and of course you see that first combination already would give me 3 decimal places, so I would have to come back and remove this and turn it into a 1, not a 0.1. Or I could do a 1 and a 2.4. So there are a lot of combinations that would work there. But I can see that that's not going to give me the 1.1 in the middle that I'm looking for, so that doesn't bother me. As I look on through here, I'm real interested in this 3 and 8 combination. So the question becomes, can I position the decimal so that when I multiply them I get 0.24? And when I add them, I get 1.1. And I'm thinking that if I put the decimal in front of each of those, let me double check that, 0.3 times 0.8 would give me a 2 decimal place 0.24. And if I add them together, I get a 1.1. So if you'll remember that when you're adding decimals, you align them and you keep the decimal in a straight line. When you're multiplying them, you go ahead and multiply the numbers and then remember how you count off the decimal places. So that's the combination that I want, 0.3 and 0.8. All right, so let's go over here. And remember how this works. You copy down when the Lie coefficient is not 1. Again, it's a more complex process. So I like to copy down the first and the last terms and then go in here into the middle . Forgot the plus there, and replace the 1.1x with the 2 things that I found in my chart. Oops, I reversed the order from what they are in my chart, but that doesn't really matter. All right, so now I'm going to do a grouping process. I have 4 terms, so I'm going to group the first pair, put in a plus to act as a separator here. I like to think of laying tiles, how you put those little spacers in, and that plus is a spacer to keep the 2 parentheses acting as sums. So as I look at the first pair, I see that I have a common 2 and a common x. And as I look at the second pair, I see I have a common 0.3. And we'll have to do that. I hope it's going to come out to 0.4. Let's see. So the way we work with a common factor is we take this 0.12 and we divide it by this 0.3. You could, of course, type this in your calculator. I'm doing it the old-fashioned way. There, that's correct. So I do get a 0.4 there in this position right here. All right, so I'm ready to finish it up. I'm seeing, remember when we did grouping, we're hoping we get matching parentheses, and we do. So I'm going to pull out that common matching parentheses, and then what's left, or what remains in the second parentheses, are these two terms that sit out in front of the common parentheses. So that's the way it would look when you factor it. And you can see that as I look at, just checking it here, as I look at last times last, you see that's going to give me that 0.12 on the end there in the original. If I look at first times first, you see there's the 2x squared, which is the first term in the original trinomial. And then if I look at the outer product and the inner product, those two will combine or add back up to the 1.1x in the middle. All right, so there's the first one. The second one starts off with 4 terms. So I'm going to go ahead and, well, first you want to look and see if there is a greatest common factor all through all 4 terms. And there is not one other than 1. So I'm going to go ahead and start the grouping process. And the problem with this one is going to be signs. So again, there I am putting the plus in the middle as the separator between the two parentheses. Notice how I maintain this negative that is attached to the third term x, and I keep that inside the second parentheses because it belongs to that third term. All right, so looking at the first pair, excuse me, I see a common 2x squared, which leaves x plus 0.2, I think. Let me think about that for a second. I'd take 0.4x squared and divide it by 2x squared. Of course, these x squareds are going to cancel out. And then 2 divided into 0.4 gives me 0.2. So that looks good. All right, so now moving to the second parentheses, since both terms contain a minus out in front, negative signs out in front of the terms, I'm going to go ahead and factor out a minus sign, and I'm going to actually write down the 1. And all that's going to do is reverse these two signs so that they're now both positive. You can see if I multiplied these back together by distributing that negative 1, it would take me back to the parentheses above. So I'm happy that I've done that correctly. All right, so remember when we're doing this, we're looking, hoping that we get matching parentheses, and we do. So I'm going to go ahead and pull that out in front as my GCF, my greatest common factor. And then again, the second parentheses is going to contain this 2x squared and this minus 1. That's why I wanted to go ahead and write down that minus 1, actually put the 1 out there so that you could see where this is coming from in that second parentheses there. right, so that one is a 4-term grouping. The next one is a 4-term grouping. So again, unfortunately, this one has no decimals in it. And I'm looking through to see if there's a GCF in all 4 terms, and there is not. There's the plus separator, and notice how the negative stays with the term 8V. Here's my kitty. Hello, kitty. Okay, so as I look at the first pair of terms, I see in common a 2, and I also see in common a v squared. So I'm going to pull that out, and that's going to leave 8v plus 11. And on the second pair, again, since they're both negative, I'm going to pull out that -1 like I did before. So these two, number 2 and number 3, are very similar. You notice what that does there when I pull out that -1. It takes this negative and reverses it to a positive, and it takes this negative and reverses it to a positive. And again, as we said before, if you redistribute that -1, you will see that it takes you right back to the previous line. All right, that's looking good, because now I'm seeing again these matching parentheses, 8v plus 11. So again, I'm going to pull that out as the common factor, set it out in front, and then the 2v squared minus 1, again coming from here and here, is what goes into the second parentheses. All right, so that's another one that's 4 terms grouping. And the last one, we're back to decimals again. This is a trinomial. There is no GCF, but it does have a lead coefficient of 1, which makes it easier than the first one we looked at. Once I find the numbers in my chart, I can go ahead and put them directly into parentheses. I don't have to split up into 4 terms and then run through that grouping process. So again, let me go out here and create a little table. At the top of that table, I want positive 0.10 or 10/100ths. And again, there are lots and lots of ways I can place decimals and multiply this together and get it to come up to a 0.10. The 1 and 10 I'm not interested in, but the 2 and the 5 I am interested in, because if I multiply 2/10 times 5/10, or 0.2 times 0.5, I can get this positive 0.10 at the top if I make them both positive. And if I add 0.2 to 0.5, I get 0.7, which is what I'm looking for this middle term back here, positive 0.7. So I think I have found the correct combination, 0.2 and 0.5. And again, because the lead coefficient is 1, I don't have to do this, spreading things out and coming here in the middle and doing all of this extra work like we did on the previous ones. I can go directly to the numbers that I found in the chart over there. So that's why these become much easier problems when that lead coefficient is 1. And of course you can see, if I do a little quick check here, when I do the last term times the last term here, 0.2 times 0.5 is 0.10. Remember, when you multiply these together, you count off decimal places for each of these decimal places up here in these multipliers. And if I do a quick check on the outer product and the inner product, you can see how those would add back up to that middle term. Okay, so I hope that helps on these these multiple types of examples on factoring.